So, we are discussing about sorting techniques, and sorting is used to sort a collection. Collection consists of any type of data. Now, today we will discuss about programming aspect of different sorting techniques. We have learned about the different sorting techniques, their concepts and their algorithms, their complexity analysis, but now we will just try to learn about how to program those sorting algorithms. Now, before going to start this discussion, I want to mention one important thing. Programming that I will discuss is just for a hint, but if you should not just only run the program, rather best idea would be that if you understand the logic and then follow some algorithms, whatever the algorithms I have discussed in this course, that you can follow, or the algorithm those are there in many books, whatever the things, if you learn that okay, this algorithm you are more comfortable, you can follow this algorithm, no issue, then try to write the code of your own. So, here whatever the course that I am going to explain or illustrate, this is for your hint only. So, you can check, you can see that okay, program is running, but you will not be happy for that. Only the thing is that if you can write the code of your own and then run it, and then you should feel happy it is. Now, so this code that I am giving you, this is just for your hints only, so that in case suppose you find it difficult to write the code, you can follow that okay, how it is being implemented. So, this part that is important. Now, let us see what are the codes that we are going to discuss today. This is related to 4 different sorting algorithms I will discuss, namely insertion sort, selection sort, bubble sort and heap sort. And here again all the sorting algorithms that we will implement, considering the generic only. Generic means that you write the code once and then apply these codes to sort any type of data. So, that is a generic programming we will consider. In many of the books you can find only the simple sorting techniques to start to sort integer data, but here you should run the program, right, whatever the program I have given, or you can write the code, then you should try to run the codes for any type of data, including your user defined data type also. That will be the most advantageous from this course, that if you can do that. Okay. So, let us start about first insertion sort technique. The program of the insertion sort. I just do not want to discuss the sorting algorithm again, because I understood that okay, you have already covered it. So, it is the prerequisite for this. So, this is the insertion sort concept that is there. Algorithm I have already mentioned, you can follow this algorithm. I have followed this algorithm of course in this programming practice. Now, here is the code, you just follow the code how we have to write the right. We are declaring a class, the name, this class is declared as a generic class as we have said. So, this is the T, that means this class can take any type of data, but here we have to take the extents, as you know this basically limited to the data which basically comparable. Now, here the T, the comparable type, there are many data types, those are comparable like all numeric data types, those are basically subclass of the class numbers, like say integer, then float, and then long, short, double, whatever it is there. And also string type, string class is also comparable. So, this T basically any subclass of the class number as well as string is basically you can use it. Otherwise, if you want to use this sorting algorithm for your own data type, say student, person or whatever it is there, then you have to implement this comparable method, they compare to method for this class comparable. So, you have in this class you can write that overwrite compare to. So, a method compare to can be written for this class, then overwrite. That procedure I will discuss also. I have discussed in earlier discussion also, I have used that kind of concept, but here again I will give some idea about how you can use it. Anyway, so this is basically the concept that you should follow. That means that you should write a generic programming, that is good only. And this is the class that we this is the this is the method, right, which belong to this class. The method is basically the implementation of the insertion sorting algorithm. This method takes an array of elements of type T, and this require another argument. It is called the what is the size of this array, that is needs to be passed. Then this is the simple logic. It is called the logic that is discussed in case of insertion algorithm. It basically start from the current location to check that whether the elements to be inserted in which position according to the partially sorted list. Actually, this logic is implemented here. Okay, and that you can write, you can check it, and here we are using compare to. In this number already compare to method is implemented, but you can override this compare to method, so that for any other data type other than all those comparable type we can apply them. And so this is the procedure. It is just simply whenever we found that the element needs to be placed here, so we just simply swap the element, and that is the main logic of the insertion sort. So algorithm we have discussed, and then implementation logic is so simple that you have checked it. So it is very simple, so you can follow it. The code is written in a little bit professional ways, so that it is most compact and then robust code, and you can use it. And then finally we can write a driver program, so that you can test this code writing a main method, and this basically is a code to print the array, that is simply for loop only we have used it. And here is the main method, the main class actually, which is basically to test whether this program is working or not. So here the main method which we discuss within the same class actually. Otherwise you can write another class and say it is insertion sort demo, and then you can call this method including that class declaration here. Anyway, so here we consider an array of objects. So this is the array, and you just note that integer array we have declared because it is a generic, so we have to pass the object only. So that is an integer array. So if you declare int array, it may not work for you because this is generic. So integer array to be declared as an object like, so this is a wrapper method you have to call. So this is basically the elements which is stored into this array. Array is an array of integer objects. So these elements, n is the array dot length, because automatically compute how many elements are there. You can print array, the method we have already declared there to print the elements, and then call the method insertion sort, passing this array as an argument, n is the length. It basically sort the elements and then print the array. Right now, so this is the program that okay, it's a simple few lines of code, and that occurs that basically that matters how it sorts according to the insertion sort. Other sorting algorithm in the same line actually, only the logic is different, but it is more or less same actually. And here again I want to give some hints about or other tips that you can test it using different type of array. Here I have used a random array. You can think about array where all elements are same, or you can consider an array of in ascending order or descending order. So different way you can think about it, and then you can run the program for different inputs. And another consideration that you should do is that you can generate some random numbers, very large set of random numbers, and store the random numbers in a file. You have already covered about file handling, and then you can read the data from the file, put into the array, and then store into the integer array, and then you can call this. So that will be the good way that you can run your sorting algorithm for a very large set of numbers. That is the good idea. I hope you have understood it. So that you should follow for all sorting techniques that you will write programs. So this is the insertion sort. Now let us consider selection sort. The algorithm we have already discussed in details with illustration is basically select the minimum elements and then take place in the minimum element in the ith position if it is in ith iteration, and this is the algorithm that we have given to you for your understanding. It requires some few codes like swap because it requires to be interchange, and this is select min, how to find the minimum. This is the algorithm, very simple algorithm. Finding minimum is a very simple task, and then it is basically the main selection sort that you can do it, and here is the code that you can follow. So, again we just declare one generic class, name of the class is selection sort, it is comparable, so that any type of data, and this is the method that we are going to discuss. It is basically same ways that the insertion sort we have done, and this is the logic of the selection sort that we have discussed about it, and this is basically the method that we can find about the swapping, and that is okay. In the finding the minimum and swapping, it takes place in the same line actually here, and then next part of the code that you can think about, it is basically how to find the print, how to print the array. So, that is the sub method or auxiliary method we can write, and then finally the main method that you can discuss about here. Here is the main method. So, this is the main method. In the same way we tested the insertion sort, in the same way we can create an initial array, and then you can just sort using selection sort here. Here again we have considered integer array, right. You can consider some other type of arrays like long, float or double, short. Even you can consider the string array also, where the string can be put it, and then you see that this algorithm works for any type of data including string also. And if you override the compare to method for your user defined like student, person and everything, then you can create the array of objects, and then you can call the selection sort for this array in the same, only this part will be different, and then the defining the compare to method will be different. Then you can use this algorithm to sort any type of data that you want to sort. So, this is the selection sort, and then let us discuss about the bubble sort. Bubble sort, you know exactly how you can do it. N number of passes it is required. In each pass the largest element will go to the bottom direction, and then smaller number will try to pop up little bit upwards, and finally after n minus 1 iterations all elements will be in sorted order. We have discussed the algorithm, and this is the algorithm that you can follow. Swap method that is required for interchanging, that you can do. And another thing that you should consider here, we have mentioned that the bubble sort can be little bit modified to sort the element more efficient way for an input list when the elements given in an already in sorted order. Otherwise, whatever be the best case, worst case and average case, it usually takes order of n square, but with this modification the best case can take only order of n time, that means with only n number of comparisons that is required. So, a little modification, that a flag that you can use it. So, we have implemented this version of this, that means modified version of the bubble sort, where we use the flag here. So, now let us see, there is again generic implementation. This implementation I have done in the same way is the previous one. So, we declare a class, the same the array we declare it here, and this basically we just create a constructor. This is a little bit different way, that basically same way we can do earlier also, but it is basically we create the array, initialize the array and then read the data, that is okay. Reading the data, the get data method we can call integer I, and it basically return AI. This basically if you want to print the data like, so in case of print data method you will call it the get data, and this is the print method. Okay. So, this is a little bit in different way the algorithm, you can follow the previous method also to define it. I just make it twist little bits. Okay. So, this basically define the generic class, and finally I will include the method here. The method is the bubble sort. The method is declared here. This is the method bubble sort is included, right? And here we use the flag. This indicates that okay, that flag is initially true, that means we have to continue the loop, but whenever we see that there is no interchange, so we can make the swap false, and then it can here if we do not write false, then if we find any interchange we can make it true. Initially it is true, that means we have to repeat it, and when we just enter the loop we can make it false. If there is no thing, nothing occurs here, then it remains false, then means that your sorting is done, all elements are already in sorted order. So, we have to quit the method, and quit the loop actually, then it over. So this basically the bubble sort. The logic is basically same way that we have discussed about. That means you have to compare two adjacent elements and then swap them if they are not in order. That concept is basically followed, and this code is an implementation of the same logic here. And this is the master program that you can consider. In this master program, just okay, this is the one code we have written there, and this is the main method, this is the input list, and this is the integer array created. Then we print the array, then call the bubble sort and then print the array. So we can test the program again for the different arrangement of the elements in ascending order, all same, in descending order, random number, very large set of numbers, and then again try with different types, integer, long, short, float, string, even user defined also you can think about it. So this basically the idea that the bubble sort algorithm works for you. Now let us another sorting technique, the heap sort. Heap sort is bit lengthy procedure, but again it is also good one, and the algorithm that we have a logic you are hope you have understood it. Here array of integers needs to be stored is an input, and this is the procedure that you have to consider. First you have to create heap, so one routine can be written for that. Then remove max is basically deleting the root node, and then again rebuild the heap. So this algorithm is given there. This is basically the main sorting method, which basically call these are the sub methods are there, and this is the create heap method, and the remove max method is there, and rebuild heap method is there. Now here is the programming. You can just okay, based on the concept that we have discussed, this is the programming. So programming, again generic programming, as you can see here, this is the declaration of generic class. These are the few fields we have declared. One is basically array where the heap will store. So this is basically data. This is the total number of elements, the maximum size of the array actually, that is okay, fine. And these are okay, the location is a pointer from 0. Now we are considering mean heap. The logic that we have given is a max heap. Again you can rewrite this code or revise this code so that it can work for the max heap. I have intentionally given the mean heap because in many of the book only max heap is discussed. Now let us see the mean heap and how it works. So this basically the logic that you can think about how it works actually, and that basically okay. So this is the next part of the code. Here is the next part of the code, the parent. These are auxiliary code, left child, right child. It is required because the next part of the code that basically require which is the parent, which is the left child, right child, is basically we are storing the heap tree in the form of an array, and as we have to move from any node to the lowest, I mean towards the children node, or sometimes we have from the children node to its parent node. So this kind of method can be called for them, and here is the logic. There is a program that is the next part of the program that you can think about, and there are few more code, the is, leap, and then swap. These are very simple code. This very logic is so simple, you will be able to follow it. And here is this is the print method. How to print the heap is just printing an array, that's all, nothing else. And this is the main code, the mean heap. Mean heap is basically just see the mean heapify for all elements. So removing it and then mean heapifying is there, and so this basically the code works like that way. And here is the details code about how the mean heapify routine is defined. So mean heapify routine is basically the it basically call the heap tree and then it compare the elements, and then again call the mean heapify. That means it is basically rebuild tree is there, and if required there is a swap is there, basically the logic that we have defined. So this logic is basically programming. Okay, so it is programming according to my style, programming according to your own style, maybe something else. You can follow the algorithm better and then write the code of your own. Now here compare to method we are using, so you can just override the compare to method depending on how you want to compare. Say for example student, So compare to method can be override there, and student maybe one numeric field can be used to compare the two objects in order, so that automatically take care. So you can take the previous discussion where I override the compare to method for some student, the user defined object. You can follow it here, you can add the code there, and then you can run the program again so that you can test it. And so this is basically building the tree insert there, and remove code and all these things are there. And this is the main method, that is the sorting method, which basically remove the root node and then heapify it is there. Now, so this code is basically in a fragmented way, rather written in a basically is okay, so modular way that we have written the code, but again I am telling the code is choice of your own, so you can write the code according to your own choice. And here is the master program. This program basically okay, see here what we are doing, we are defining the main method, and this is basically we call the routine here. That means we have to create the mean heap of size say 5 here, and then we consider an array of maximum size is 15. Then what we are doing is that we are inserting elements. So this basically building a heap, this basically building a heap, starting I am starting from empty heap and initially inserting one element at a time. So initially when we create the node with array A, so basically we insert 5 and then we are inserting each elements one by one. So these are the elements are inserted. So the heap contains all these elements 5 to 5, 3, 17, 10 in random order. So heap is created, and then we just after create a heap, we call the mean heap, that basically the heap sort method actually. And then if we print the heap, it will basically print the elements in the sorted order. So this basically the idea about here, we store the array in the form of a mean heap actually. So this is the code that you can follow. It may take some time to understand the code, but anyway, so you can run the code for different type of data. Here we have given a demonstration for integer type. You can took the running with the long, double, short, whatever it is there, and it will work. And for many other discussion, you can follow this book so that you can try to implement some other sorting techniques. Those are there in this book to practice more. In our next part, we will discuss few more techniques there so that you can follow it. Thank you.